Here's sample test 4, problem number 7. Use Lenz's law to answer the following questions concerning the direction of induced currents. A. What is the direction of the induced current in resistor R in the figure when the bar magnet is moved to the left? Alright, so we need to go through that hierarchy of questions that we went through to solve these kinds of problems. So the first one is, what is the direction of the original flux in this problem? Well, as we look at this, there are flux lines emanating out of the north pole of this magnet into the south pole of the magnet. So they are going this way. There's a lot of them like that. So what that means is in the vicinity of where we're interested in, which is where the solenoid is, the flux lines are actually headed from left to right. So our flux direction is to the right, out of that north pole as it's going to the right. Second question, as we proceed through this problem, does that flux increase or decrease? Well, this magnet's moving to the left, so we are getting into more of the diluted part of this field, and hence the flux is decreasing as we proceed through this problem. That's what's happening with our status quo. So now to go on, we'll forget about the magnet part of this, and we're going to focus in on what's happening with our coil over here. It's experiencing a flux that's to the right and decreasing. What's nature going to do about it? It's going to create its own magnetic field, induced magnetic field, to oppose the decrease. So the induced magnetic field is to the right. Because this second answer was decreasing, this third answer to the right was the same as the answer to number 1, and that will always be the case. If the answer to 2 were increasing, then the answer to 3 would be 180 degrees opposite the answer to 1. So our induced field is to the right, going like this, through this solenoid. To create that, we need an induced current going, according to the right-hand rule for solenoids, down through the windings. So we need a current that is going down through these windings by the right-hand rule, so that we can create that induced magnetic field. So our I induced is down through the windings. If it's going down through the windings in each one of these, then it's going down on this very last loop, which means it's going right to left through the resistor. So I induced is right to left through the resistor R. Alright, so that is part A. Let's look at B now. We need to do the same thing, ask ourselves these questions. What is the direction of the original flux? Now the original flux is being produced by this current that is going down like this, and as we put our right hand in that direction, that means there's a magnetic field coming out of the page to the right here and going into the page to the left of that wire. Hence the flux is coming out of the page towards you in the vicinity of what we're interested in. So flux is out of the page towards you as it's coming out like this and going in like that. So as we proceed through this problem, is that flux increasing or decreasing? Well, we're told that the current is decreasing rapidly to 0, and the current and the field are proportional, so this flux is decreasing as we proceed through this problem. All right, so that's the status quo. And now we're not going to worry anymore about this current itself, and we're going to focus in on what's happening with our secondary loop here. It's experiencing a flux that's coming out of the page and decreasing. What's it going to do about it? It's going to create its own induced field and flux that is out of the page to help supplement the decrease and keep things the way they were. And again, you see that since our answer to B was decreasing, our answer to 3 is exactly the same as our answer to 1 out of the page. What do we need to create this induced field out of the page? By the right-hand rule, in order to have a thumb pointing out of the page with the right hand, we are going to need a current that is going counterclockwise through this loop so that we can point out of the page with our right hand. So I induced is counterclockwise through the loop, and that means it's going right to left through that resistor. So I induced is right to left through the resistor. So there you have it. Those are the directions through the resistor based on going through our hierarchy of questions for Lenz's law for both of these situations.